The only difference between geometric and arithmetic is geometrics are separated by a common ratio, meaning you've got a number you're multiplying the terms by every single time to get the next term. Okay, it could be something like that. All right, or if I had the sequence 2, 4, 8, 16, 32, I can see there's obviously a distinct separation between them. But in this case, I know it's not arithmetic because I'm not adding something to get the next number. Here I would be multiplying. Now if I asked you, what do you think I'm going to multiply by to get the next term, it'd be how much?
20.
20? Really? You 2, right? So,
1.
If you multiply by 1, 2 times 1 is 4.
You said 1.
Well, after last night's homework, that might be. Alright, so like in this case, you would say the common ratio here would be 2. You're multiplying everything by 2 to get the next term. Alright, same thing goes there. There should be a obvious thing happening. Oh, so that should actually be 5 over 16, not 5 over 8. Okay, you can change this. This should actually be a 16. There's a typo there. You want to talk about slacking. All right, so guys, in the way this gets brought, remember they use like for the common difference on the sequences, they use the D, the common ratio here would be the R. All right, so this one, here your common ratio is 2, and here it's 1, 4. So just get it as, you know, if you're dividing, you write it as a fraction still. Everything you want as a fraction. Hence, it's a ratio, 1 to 4, 2 to 1, that kind of thing. Okay, now, if you forgot formulas for these, I would assume you do, even though you have, or you should have done these in the past. Your technical way the sequence that is geometric goes is in this manner, right? You take the ratio, whatever the ratio is, you're raising it to a power that's 1 less than whatever term you're on. All right, and that's always how it goes. It goes first term times whatever the ratio is raised to some power. All right, and if you simplify it and look at it, you would always see that that power, like I said, is 1 less than whatever term you're on. All right, because that could go on forever. AR to the 4th, AR to the 5th, so.
Really?
All right, so this right here, and now the reason I said that a lot of times these are easier than the arithmetic ones is because in this case, you know, you're not adding things. You don't have to know, like, it's more straightforward than the arithmetic ones are. Okay? At least most of the time they are. Especially with the sums. The sums are a whole lot more straightforward. Involve less work because you don't have to know 2 different terms. Like arithmetic, you had to know first term and the nth term. When we do sums for these, you only have to know the first. Right? So this is always, and if you want to put that there, just to remind you guys, the A, that's A sub 1, first term. Right? So first term, common ratio, and only this part is raised to the power. That's it. All right, so in terms of your orders, guys, make sure you understand that's the only thing raised to the power, not the A. This part doesn't get included. This is just what you multiply by after you get done raising this thing to a specific power. Okay?
Go, Bulldog.
Oh my God. Oh my, come on.
At least you're not swearing.
Okay. And roll you in like a Here you go. I know you're
No, not yet, not yet,
you're,
not yet.
you're always doing that. No, wait. Go back.
Okay.
All right. So guys, first one, this would be the most straightforward one, okay, because they're basically giving you, well, you would still find the ratio, but they're giving you first term, so it's a little easier to find the common ratio. I mean, they're starting you off with the sequence. You're still going through writing n terms and maybe finding a specific term, like in this case, this is 12, just like you did with the arithmetic. So the basic problems, like the practice of doing them, doesn't change. All right, so n term is that formula, right? By parentheses around it. First term, in this case right here, first term is how much? Common ratio. What do you multiply by to get to the next term? 3. That'd be it. That's all you need to do for nth term. There's no simplifying involved. Nothing you can do, actually. Okay, so you would stick right there. And then when you do the 12th term, yeah, it's, well, 3 to the 11th power is going to be a big number. Then I'm going to double it, so maybe really big.
I have
All right.
3,500,
Wait, no, it should be
354,190.
Yeah, that's what it should be. All right. So those would be your two answers. That would be nth term. That'd be 12th term. Okay? So this is the most straightforward, because guys, literally, all you do is take the numbers, plug them into the formula. Everything's right there. Okay? Now, to take the same kind of problem, make it a...
Whoa. Calm down. I was going to laugh.
I'll go back to it if I need to. To make it a little bit more complex, we'll give it to you this way. We're now, just like with the arithmetic, they're going to give you terms at different points within the sequence. Like this case, I'm giving you the 5th term and the 1st term.
Ooh.
Okay, which means I can't just look one number to the next to find the common ratio. A lot of times, you might be able to just do kind of a trial and error thing, like if the terms are really close together. Like this case, they're not that far apart, so you could probably realize that I'm starting with the 2nd term, and you could just try different numbers until you get like something that will get you 162 for the 5th term. That's fine. It's going to take you a lot longer to do some of these problems. Technically, the way you're doing this is, and the reason I'm doing this is I need to find the ratio. For the ratio here, the way you're going to do this is you do the number of terms that you're working with. So I got 5th term and 1st term. So 5 minus 1 is the number term I'm working with. All right, and this will always work. Okay, r to the 5 minus 1, which is 4. So I'm going to have on one side of my equation r to the 4th. The other side, remember, this is getting a ratio. So on the other side, I'm writing out a ratio. My 5th term is 162. 1st term is 2. 162 divided by 2 is how much?
81.
How do I get rid of the 4th power?
You take the 4th root off.
Your calculators have it somewhere. If you got a graphing calculator, generally it's easier to raise it to, type it in as 1/4. That's the 4th root, is raised to the 1/4 power. Like square root's the 1/2 power. Because on the graphing calculators, to get to where that root thing is, you know, where you put in the different ones, it's like under different menus. It's just a lot quicker to use the carousel.
So you just scientific calculator.
Even then. But anyway, what 81, the 4th root of 81 is how much?
3.
3. Hey, look, it's the same as last. All right, so then the other part is asking me to find the 9th term, which I needed the ratio to do the 9th term. I mean, I got the 1st term, it's still 2. Starts at the exact same place as the last one also. All right, and then it's 3 to the which is, you got an answer?
13,126.
There you go.
Yeah.
All right, so guys, when you do these, like this especially comes into play when you've got terms that are far apart from each other. Like if I gave you the 2nd term and 7th term, you're probably not going to sit there and mess with it. What? It's always n minus 1. So I'm looking for the 9th term, so 9 minus 1. All right, so this is always the highest term you have, the lowest term you have in terms of this part. On the other side are the actual number values for those terms. So that was the 5th term, that was the 1st one. These are the two numbers you subtract. Over here, you put the actual values. This will always work to find your ratio, guys. Always. All right? If it ends up being a decimal, like if it's not a decimal you're used to, and it's not easily converted to a fraction, you can leave it as a decimal. All right? But your calculators have fraction buttons on them, guys. They convert numbers to fractions. Use it. Okay? There are going to be some that we can't. Like, there are going to be a couple of the problems that we're just going to have to leave as decimals, but I'm not worried about that yet. Okay? All right. Now, next part would be taking this and doing the partial sum. And with the geometric, there's actually going to be two things you're doing. There's going to be two different sum formulas. One is for the partial ones. All right, like with the sums you did on the arithmetic, those were partial. You had a stopping point. Okay, it's considered, remember, partial sum that has a stopping point. But if you remember doing these at all, there's also a formula for infinite series, but that's only in the case that your R is a specific value, okay, or at least range of values. All right, so first thing is formula for partial sum, like that. What I'd suggest you do, guys, is kind of make sure you group that in parentheses so you understand. You do everything that's in this parentheses first, in terms of subtracting, dividing, so on, before you multiply by A. And again, that A, guys, that is the, remember, that is the first term. So in this case, you need first term, the number of terms, and the common ratio. All right? Whereas like with the arithmetic, you need a first term, last term, and then the number of terms. So it's a little bit, this one's actually a little bit easier to work with. You don't have to do that extra work of plugging it in and getting the nth term. This is things like that. Okay?
Okay.
Can I go past this?
No.
I'm going to do like one example of this, and I'll do one with the infinite ones when we get there. Okay? Wait, what? I would add that. Probably what would help if you could write it like this. Got it? Okay? You want to see if that helps? All right. Gosh, clap.
Maha.
All right, so this would be the first one I'm doing in terms of sums. This again would be a partial sum because I'm stopping at the sixth term. One this low, you could technically probably just work out what each term is, so it's only 6, and then add them together. You'd create more work for yourself probably doing it that way. So you should get quick at doing these. If I said find the sum of the first like 20 terms, obviously you probably don't want to write out all 20 terms and go from there. All right, so what I'm asking here is, I'll write it down. The sum of the first 6 terms. So in this case, I need first term, I need the common ratio. Right, so I know the n, that's to the 6. I just need to know first term and common ratio. Yes.
So the A sub 1 is over the R thing? Yeah, I thought it was.
It is time.
Oh.
Right?
Not on the bottom, it doesn't.
When you multiply something by
Well, I wrote it wrong.
that number over one.
It always goes. Yeah.
So anyway, like.
Like, yeah, you understand, 2 times 1/4 is not 2 rate.
Right.
Because 2 is technically 2 over 1,
Yeah.
2 over 4.
Ah, okay.
Same idea.
Same idea?
Okay.
Got it.
All right, so first thing I would probably do if I was doing this is find the common ratio. All right, so I would do the whole thing where I do the 6 minus 3, so 6 minus 3 up there. And then on the other side, I would have the ratio. So I get R cubed equals, 2, so I would assume that's 8. Is that 8? 224 divided by
Yeah.
28?
No.
Ah, do it. Someone got it. 224.
It is, yeah.
7.999.
It's 8? I get that.
Oh my God,
Lost
these
it.
talkers and being so talk, so stupid.
No, man, it's so cool.
Lie.
Eat. All right, and then guys, cube root, right? You got r cubed equals 8. Cube root will give you 2. So now you've got this part. So I can put a 2 there, 2 there. The only thing left to do is to find the first term. How do you think I would do the first term? Or what do you think I would do maybe to get back to the first term?
Subtract the difference. Yeah, no, divide
I don't
by,
need to subtract
divide by the
anything. I'm talking about
ratio.
ratios. I'm
Yeah.
dividing and
So
multiplying.
divide 28 by 2 and then by 2. Yeah.
Yeah, I could, since that's the third term, it's probably a lot quicker just to do 28 divided by 2.
But
Divided
what
by
if,
2.
but what if you didn't have?
So like the second term would be 14,
And
28
7.
divided by 2, that's 7. Technically, guys, you could do it as 28 equals the first term 2 to the, like that. It's just plugging it into the n formula, the a sub n formula. But since it's right there, if you just hit divide by 2 twice, you're going to get back to the same. Yeah.
So if we have like a really, like, if we were trying to find A1, but we only have like A of 28 and A of 48 or something.
This way right here, I would use this formula. Like if I gave you the 20th term and I said the 20th term was like 1280 something, then it'd be like 1284 equals a sub 1, and let's say the common ratio is 2, like this one is. It'd be 2 to the 9th. So you would find out whatever number that is and divide by it. Which is probably going to be bigger than that, but still, that's basically all. All right. So,
Oh my God.
all right, so guys, that was the last bit, is just getting that 7 there. So guys, I need someone to do this out. Make sure you get the correct answer here.
I
You
got-
get a negative anything for this.
I got a 441.
Because on top you got one, let's do it step by step. 1 minus 2 to the 6
Minus 63.
is how much?
Negative 62.
Negative 63. All right, so I got negative 63 times 7.
I thought you were supposed to divide
top.
this and then multiply.
You can, it doesn't matter. It'd be positive 63 times 7. It's going to give me the same answer. It doesn't matter when I do that whole dividing part. Okay? Like I said, you can either think about it as putting that number on top, or you can do all that fraction stuff first, then multiply it at the end.
Yeah.
That order doesn't matter. It's multiplication.
And dab.
So if I do this, let's just say I did the division stuff first, right? That's negative 1 on the bottom, so I get 7 times a positive 63, which is, like I said, there are, for the geometric stuff, there are 2 different formulas you might run into, guys, for the sum. First one's the one that was just up there. Okay, that's for the partial one. Infinite series can exist in terms of sums with the geometric ones, but only if that common ratio is less than 1. Okay? Obviously, it can't be like 0 or anything like that, or else you wouldn't keep creating a series, it'd be 0, 0, 0, 0, 0. So anything that is, as long as the absolute value is less than 1, so a fraction less than 1 is essentially what it is. All right? Because what's going to happen, the reason this would work is, if you have a common ratio less than that, that means the next term is going to progressively get smaller, smaller, and smaller and smaller, which means it's getting closer and closer to 0. Okay, since it's getting closer and closer to 0, that means essentially the further you go into the series, you're really not adding anything to it in terms of the sum. Like if I took a number and I added 1 over like 2,000 to it, it's technically not going to affect the number that much. All right, if I added 1 over 4,000 to it, it's not going to affect it that much. All right, and because of that reason, you can have a formula for this to tell you what the sum would be of an infinite series. All right, and it's just that. First term, okay, A again is the first term, divided by 1 minus whatever the ratio is. All right, which means, guys, you're working with fractions, leave these in fraction form. All right, they're going to be, these are pretty straightforward usually. Yeah, every now and then. Yes.
What about like if you're multiplying, like if your ratio is a negative number, is that just like?
If it's a negative ratio, that means your signs are going to alternate. So you have one positive, one negative, positive, negative, positive, negative.
Okay.
That would be what tells you it's
But I mean, that's
negative.
less than 1, so it's just nothing.
No,
it's like
that's
that.
why it's absolute value of R is less than
Oh, okay.
1. Okay? Like I know what you're saying. You're saying like -3 is less than 1 kind of thing.
Yeah.
Yeah.
Okay, I wasn't paying attention to that.
Yeah, it has to be the absolute value. So you're only looking at the positive number, like pretending it's negative 1. Okay, so an example of one of these guys would be something like this, where the difference between this and let's say the partial sum on the sub yesterday is I don't have a plus and then a number here, so no, it's not ending somewhere, it's going on forever. Which again, like I said, this means that this number that I'm essentially adding is getting closer and closer to 0. Like it's essentially going to become non-existent in terms of affecting the sum of this series. Okay? So that means that I can use that formula which is just up there. By doing on top the first term. In this case, the first term is which one?
1.
And then 1 minus whatever the common ratio is on the bottom. In this case, the common ratio is what? 1/3. All right? Work with the fractions, guys. 1 minus 1/3 is how much?
2/3.
And 1 divided by 2/3 is?
3 over 2.
That'd be your answer. Okay? The infinite ones are usually easier to work with because all you're doing is like one little subtraction. You'll have like first term for these probably most of the time, and the common ratio would be pretty straightforward. All right, because these don't come up that way. All right, so what I want you guys to do right now. Oh, two problems I want you to do. Yes. I'm gonna give you guys the answers here, okay? Then we need to work out what we can. This
I'm still
first
getting-
line, common ratio there is 1/4. Everything's divided by 4. When you write the nth term, it should be 12 times 1/4 to the n minus 1. The 10th term, if you wrote it as a fraction, if you took the time and did that, you don't need to, it's 3 over 65536.
Okay,
If,
so,
graphing calculators, if you did this, are going to have it in scientific notation.
Wait,
So
wait,
it's
wait.
point 0.0000458 around 3 centimeters.
we're putting it in.
It's in the calculator. It should say something like 4.58. At the end of it, it's got the e to the -5 thing. Times it to the -50.
Can you work that out? Because,
Yeah, how did,
Plug
Oh,
10
my
in there.
bad.
okay, and I
0.25 to the 9 times 12.
I put in my finger.
no, I know that, but, okay, whatever, I just want to do this.
You're wrong. You're wrong.
All right, and then
Wait, how do you
Wait,
get
what?
to, how do you
What?
get to, like, you know
have to find S.
Like, in the calculator, it says 4.57 and then a bunch of numbers and it has the minus, like, 5.
Yeah, remember this is the E means times 10 to the negative fifth.
Okay, so how do I,
So
like,
move the decimal place backwards 5, right? So 1, 2, 3, 4.
Oh, okay,
So that's why there's 4 zeros there.
okay.
The other one here, guys, at the bottom, the common ratio,
It's 1/5.
1/5.
Oh, yeah.
The fifth term, 0.04. Again, just plugging in right, 25 times 1/5 to the 4th power. And then part B, the sum of the first 8 is 31.2.
Yeah, can you explain that?
25, 1 minus 1/5 to the 8 over 1 minus 1/5. I don't know, somewhere in that math. What I would do is do this part first, subtract the 1 minus 158, which is, I didn't work that out, but anyway, I would do that first. Just assume it's like, I'm sure 0.9 something. And then multiply that by 25, and then divide it by 0.8. Because 1 minus 1/5 is 4/5, or 0.8. Yes.
I seriously doubt that that's correct.
You do? Do I have to disprove you again?
Yes.
Whoa. Everyone else is like
How do you do 1 minus 1?
Like that one where
Oh,
we got a fraction that's like 1/5 to the 8 is essentially 4. It's not going to affect it. Okay.
Oh.
Last 2 things. There's 2 more things, okay? I'm going to do an example for each one. But essentially all these problems in the section that's just finance. And it'll be clear, like you'll get, there's 2 sections you're doing today. So the first is the geometric sequence series thing, and then the next thing is the finance part, which ties into it because the formulas that are going to be up here really relate back to the geometric sequence one. So, but instead of you having to derive these on your own and deal with them that way, the book has them. All right. If you ever forget them, you can work around these problems using geometric sum formulas or geometric sequences. Okay. The first one here. And this is the amount of an annuity. All right. By this formula, guys, in the book, it's page 849. Know the page because when you do the work tonight, you're going to have to go back to it anyway. So this is on page 849. All right. Like I said, that right there. If I have a problem that involves this, I'm going to give you that formula, even though it actually is the whole geometric sum formula.
It really isn't.
Okay?
Is that A of
It's A sub F, I think.
Oh.
Yeah, it's A sub F. Okay?
I'm trying to, I swear.
Like that.
I literally pressed pause and it kept playing.
So guys, the only thing to note, like, so this part, this would be the amount of the annuity, right? Like savings account kind of thing. R would be your initial amount. I is whatever the interest rate is. And N is however long your time period is. You're going to see one of the examples deals with
What's L?
What was R?
no other.
What was R?
Guys, go to this page and look at it. Get a book, go to that page and look at it.
You gotta wait.
So listen, with the I that's there, right, the interest rate that they are referencing here, okay, is kind of in terms of a yearly interest rate. When you do anything with money, right, when they say APR or anything like that, that's the amount of interest that you would receive for the entire year. Now, there are options to this. You could have something that says compounded yearly, which means you don't change the interest rate in the formula. If I did something like compounded quarterly, that means every quarter, so every 3 months, interest would be added to your account, savings account, whatever this is. And in that case, you would have to change this number in the account. The second example I do will have something where it's compounded, not yearly in it. So I'll show you how to deal with it when we get to it there. All right, just kind of keep in your head, the whole I thing right here is for compounded yearly if it's just dealt with the way the formula is. Yes?
What is F, like, if you're doing amount?
I don't know. That's just about it. I would assume amount of the fund, like that.
Fund?
Fund amount. The funding is what you're calling it.
Oh, the fund, okay.
Amount of the fund.
Yeah, there you go. Amount of fund, right?
You're calculating the amount of fund right now. This is like off the charts.
It is, yeah. You're doing 20, it's great. All right, so this, guys, would be a very basic problem in terms of finding the amount of an annuity. Which annuity, guys, is like some kind of savings. It's telling you the number of payments, telling you like the amount that you start with, okay? And it's telling you the amount of interest you're going to get each year.
Can you just go ahead and do 20 times 5,000?
Yeah.
Why not?
Because you got to take into account the amount of interest that is getting added on to what's already in there.
Take it to account.
So can't you just
Okay.
do 0.12 times 5,000 and then whatever that is?
That would be a simple interest problem because that would be saying I'm going to get that amount every single time. But what's happening, if I do this, that means like the first payment I put in, I got 5,000. So
Oh.
I'm getting 12% interest on that.
And then,
The next one's going to be 10,000, whatever, because now you got the interest part from this
Yeah.
one added into
Then
it.
you have
So
to
then you're
add-
going to do 12% of this. The next one's going to be a little bigger, 12% of that, so on and so forth. It ends up being, this is like, in terms of the whole geometric sequence, that ends up being like the common ratio. Okay, and the 5,000 is like the first term. So you could technically go in there and use the whole sum part for this. And n would be the 20 would be the number of terms. All right, so in terms of the formula that was up there, guys, when a to the f equals. Okay, again, I know the r, right, was out in front, but it's out in front, it's technically in the numerator. I just like to keep things nice and neat for the numerator and denominator. So I'm putting 20 there. Or the 5,000, sorry. Sorry. 5,000.
What is that?
This is the initial amount, or the amount of each payment in this case. Okay? I always just think of it in terms of the interest formula, because they're about the same. Then on the inside of your parentheses, right, you got 1 plus whatever the interest is. 12%, guys, is 0.12, you're dealing with percent. You're doing it right. The next thing would be whatever time period you're dealing with, or however many payments there are. In this case, it's 20. Again, that's like the N, right? That's 20.
wait, the whole thing?
That's 20. All of that is on the top.
Yeah.
All right? Then on the bottom, you just have 1.12 part. It's the I, the interest. Okay? Now here's what I was saying. Like the next problem I do, this interest is going to be something other than per year. Like I'm going to give you an interest you get per year, but I'm going to say it's going to go into the account multiple times a year. And I'll show you how to deal with that then. Okay, in this case, since it's just per year, there's nothing talking about compounded monthly, bi-yearly, annually, quarterly, semi-annually, anything like that. You just deal with 2020. All right? So now it's just a matter of working this out. Like I would do it as doing this part first. So I would do like the 1.12 to the 20th power. Okay, so this would become 5,000 times What's 1.12 to the 20th? Wait, say it. 646. All right, then it would take that, multiply by 5,000, and then subtract the 1 from it. The minus 1 is just because, in the sum formula, they have 1 minus r, so that the geometric series is the same. All right, so you'll have 48230 on top, using the numbers that are up there. That's after I multiply by 5,000 and subtract 1. It's just a matter of dividing by that, divide by 0.12, and that would give you 401,000. Using the numbers that were there. From the time I rounded right here.
I got all 4 dollars.
Yeah, I didn't round this. No, it's like I got 401, 920.5 without doing any kind of learning at all. I used this. Like the calculating, I just used this number. No. But guys, really, these problems aren't going to be any more than you plug the right things in the right spots in the formula. Okay? The second thing is look for this one. This is on page 850 and 851. Now there's 2 formulas there, but they're both the same. They're just rewritten. Like this one, we look for, guys, that's on page 851. It even says installment buying on it. If you look on page 850, it's actually the exact same formula, just solved out for the present amount, the A sub B thing. Okay, so if you do the present amount, which the way these are set up, doesn't matter which one you use, as long as you have the variables defined in the right way. So you could technically stick with one of them, either this one or this one. This one will look like A sub B equals R 1 minus over I. But these two are essentially the same. Okay, it's just a matter of what is solved out for. So the way the problems are set up, like if they said that, like this one here, they say, okay, you have a certain loan you're getting, and you want to find out how much each payment is going to be, or roughly how much each payment is going to be, depending on what your interest is. If you want to find out how much each payment would be, you would use this one. If you knew how much you were paying per month on something, and you want to figure out what the actual amount of the loan is, or the present amount, then you would use this one. So depending on what the question's asking for would depend on which one of these you use. Yeah.
And you're going to give us these formulas so we don't have to pick
If I give you one of these on test, I will give you,
all right.
even though they are technically go right back to what we did earlier today.
Hey, can you go over which one is which again?
Present amount's this one. So that means if I want to find out how much the loan is, it's here. This one is if I want to find out how much my payments are.
Okay.
So 851 is the payment one. That's the payment. And 850 is the total amount, or the amount of loan.
Like how much?
If you want to think about it that way. What's that?
So, I mean, I know you just said it, but like, the bottom line is like how much you still have to pay back?
No, how much your loan?
Yeah, like the present value.
Well, yeah, so.
Yes. if you want to think about that. All right, so the one example I'm gonna do, as long as you got the numbers down, you can see, like the page number. All right, so with this one here, okay, this one here would be asking what's the price of the rent. So if I was doing it with the last one, and I'm given how much I'm paying per month, and I'm given an interest rate. It means I'm paying back a loan, so that means I'm going to be dealing with the present value. All right, so in this case, I'm going to be working for the formula that goes, the A sub B equals R 1 minus so that here's the thing with these. This part should be obvious. That's the amount you're paying. That's your R, $30 a month. This is right here technically the interest rate. But in terms of this formula, like my formula is not going to look like 30, 1 minus 1 plus 0.1. That's not going to be right. Okay? The reason is because it's compounded monthly. That means that 10% is essentially spread out throughout the year. Okay? So what you're actually going to have to do, if they ever see anything that says compounded, when you do the I for this formula, you're going to take the actual rate that's per year, so 0.1 is per year, and you're going to divide it by however many times or how much that is spread out throughout the year. So if I'm spreading out 10% every month, right, there's 12 months in a year, correct? So that means it's spread out evenly between those 12 months. So this is going to give me what value buy I'm going to actually use. If it said compounded quarterly, that'd be divided by 4. Biannually would be every half year, so it'd be divided by 2. Okay? So in this case here, I'm going to use, this is 0.0083. All right, so instead of 0.1 right there, it's going to say 0.0083. That's just what 0.1 divided by 12. Now, the other thing that comes into account, the N. This says right here is paying a month for a year, 1 year. So I'm not going to, for my N, right, I'm not going to use 1 for 1 year because I'm paying every month. So again, how many months are in a year? 12. So that's 12 now.
So do you always use months? Oh, no,
in this
no,
case,
no,
I do
okay.
because it says
Okay, yeah,
per
if
month
you,
and compound.
since you changed the rate over a
Yes.
month, okay.
Usually whatever this is what you want by. Like if I did this for 2 years, this would be 24.
Yeah.
Okay. And then on the bottom would be 0.083 that I did. So I would just point that. All right. So working slowly on these. 1 plus 0.083 raised to the 12th power is, or negative 12, sorry, not positive 12. It's negative. Can someone do that for me? The 1.0083 raised to the negative 12.
Oh, 0.9055.
9055. Right, 30 that. 1 minus that divided by 0.0083. Like what is 1 minus 0.9055?
0.0945.
And then 0.0945 divided by 0.0083.
11.3855.
Okay, and then the last step would be multiplying that by 30, the amount you're paying every time.
341.5.
There you go.
30. Oh, wait, I have motion?
Nah, that'd be Yes.
And shouldn't it be for his fiance, not his finance?
For his finance, he pays his finances away.
Finance, I thought you were
That's
doing-
sweet, really?
I need that.
Buys a ring for his finance.
Yeah. Thank you for being my finance.